All right, so efficiency, electrification, and digitalization is what Katie was speaking about, and we're all on board. We've been together for a couple of days now. So what I realize in this journey that we're all in, and I'm glad to see all the happy faces here, is it takes an army to get to where we need to get to. We can't do it alone. I think all of us need each other. And let me introduce my topic today is energy transition and the critical role of smart buildings and how it plays in it. My guest up front is got Stephen Lamb from Bloom Energy, head of sustainability. Welcome. Richard Newell, C3 AI, Chief Technology Officer. Welcome back. John Hoekstra from Prologis, from SVP of Global Sustainability. And Kurt Miller from the City of Ansonia, Connecticut, Budget Director. So let me clip this on me. All right, let's start with the first question. And think of questions. We are going to open it up to the crowd afterwards. So we'll have a couple leading questions, and we'll get your input here in a minute. So we'll start with Steve. So Steve, how is technology and innovation changing and evolving the solutions available for cleaner, more efficient energy?
Well, thanks for the question, and a pleasure to be here. Thanks for allowing us to be part of the collective this week. Stephen Lamb, Director of Sustainability, Bloom Energy. For those that don't know Bloom is a fuel cell and electrolyzer manufacturer based in San Jose. We have historically deployed fuel cells for stationary power generation behind the meter at C&I locations around the world. Got about a gigawatt deployed, about 1,000 projects. But what we've seen over time is a real call for flexibility from our customer base. That's contracting flexibility, and that's the flexibility with respect to how we decarbonize our solutions. So, the world's moving quickly. There are a lot of unknowns about where things are going. And so what we've seen in the data center space and beyond is just folks calling for options. So I'll leave you with that as my primary point that I want you guys to take away from what we see on the ground. What that looks like for us as a fuel cell player is short project lives, as short as 5 years. It looks like carbon capture ecosystems evolving, and it looks like hydrogen ecosystems evolving. So we make hydrogen through our electrolyzer business, but we're also using hydrogen in our power business. And we see a lot of folks that are looking at really novel solutions, blending hydrogen, blending stamps, so that you can think about deploying something today, perhaps islanding a microgrid so you can get your project up and running, dealing with some of these capacity constraints. But then thinking about blending hydrogen over time, or having an asset that you could think about doing something more novel with over time. So happy to say more on that as we move along, but I'll leave it there.
All right, thanks, Steve. So Kurt, how about any thoughts? I mean, you have a lot of things going on in your community. You want to share on what you guys are doing? And
yeah, so Ansonia, Connecticut is a small, distressed municipality, old industrial community on the Naugatuck River, kind of centered in between New Haven, Bridgeport, and Waterbury. I had a bunch of stuff I was going to say today. I was very well prepped by one of our project engineers, Dave, but I actually want to go to some of the things that Katie said, because that really resonated with me. As a non-technical person, as more of an end user of the things that all the folks up here are going to talk about, it's real world what she's telling you. The impact that projects like this has on towns and cities is incredible, because it gives us the ability and the opportunity to not only control our costs with electricity, but at the same time it creates revenue streams, which we can now use to reinvest in other capital needs and things like that in the community. So it's an absolute home run, and I know a lot of times you come to things like this and you hear theory. You hear this is a great idea, and you never necessarily get to hear, well, the true impact of it. So I'm able to speak today of the true impact and the benefit that we get from these projects. It's incredible, and again, as a distressed municipality, by putting in a fuel cell, which we're working on, if we could bring a data center or something like that into our community, it's a complete game changer for that. So if there's any data centers in the room, I would love to take you for drinks, dinner, wherever you'd like to go, and we can talk about making that happen.
That fireside chat will be very interesting for you now, right?
Absolutely.
So thanks, Kurt. So Richard, we'll go to you next, okay? So your solutions of accelerating the decarbonization across buildings, how will AI change how we think about energy demand, the transition to cleaner energy, and grid management?
Yeah, thanks. Thanks for that question. So I lead our sustainability-related applications at C3 AI, which, if you're not familiar with, is an enterprise AI software company. And AI really touches, as I was thinking about it, so many different parts of the built environment value chain. So if you think about the equipment in the building itself, we've heavily digitized. There's sensors on so much equipment now, spilling out real-time information. The question is, how do you take that information and actually make it actionable, right? So it's not just spilling into the ether, that it actually can help you improve efficiency, reduce energy use, reduce energy costs, reduce emissions. And so we're working with companies, like Johnson Controls in buildings, doing things like, given the different temperature and other comfort features that you want to meet in a building, can you do that with lower energy use? Through things like anticipating maintenance needs for equipment. So you can start to see both in the history of a particular device, as well as that device compared to other similar devices in that building and in other buildings connected to your network, you can start to understand malperformance and then send somebody in there to do some fixing of the equipment. The thing is, you can do forecasting of that. So you can anticipate when something might be potentially breaking down in the future before it actually happens through the type of data analytics that is coming off of the equipment. Other thing would be the building itself. So not the equipment in the building, but you think about the materials used to build the building, the cement, the steel. So working with a company, Altsman, which has major commitments to decarbonizing the process of cement. There it's about reliability. It's about energy management in a very energy-intensive and carbon-intensive process. You can also use AI for learning. Research, so identifying new material compositions for cement. So that's a really important element of it. Then you start to think outside of the building, where do you source your energy from? Right, so you're connected to a grid, maybe you're connected to a fuel cell. Actually, we're working with Bloom on process optimization for the creation of fuel cells. So how can you optimize the process, make the manufacturing process more reliable, bring down the cost, which then makes it more competitive with alternative, maybe not as clean technologies. Then you think about the grid that you're connected to and integrating variable renewables. Well, AI can be very helpful with things like forecasting wind in real time at very granular locations, forecasting solar radiation so that you can anticipate when there's going to be some irregularities in the grid and be prepared for that. And I'll give just one final example, which actually I was thinking about the title of this conversation, Cracking the Code. And we have a lot of interactions with state and local governments, and one of the biggest pain points with state and local governments is actually building and permitting processes. We hear that again. And so we're actually about to launch a pilot with a big city, actually, that is going to bring AI into the permitting process. And so anybody who's engaged in really anything involving any kind of building, which is so important now with the energy transition, the amount of document handling and intelligence that you need to even understand what you need to comply with in a particular location. AI has, and natural language processing has a real capability to help us speed that process up. So there's just a few.
I love listening to you speak, and all my colleagues from Johnson Controls, like our digitalization program that we're working is like we're trying to connect panels, connect anything that's in the building that we can provide data. And I know that a lot of the Johnson Control teammates were like, well, what are you doing with the data? Like, we'll give it to Richard, right? Right? You can make good decisions, and whether we use AI with helping our technicians make quicker choices and improve their efficiency and their work orders by 30%, right? There's so much more, and that's the piece that we're on a journey. So I love your explanation. I know we got a lot out of it. So John, I don't want to leave you out. Let's give you your question. As one of the largest clean energy real estate management companies in the world, you are progressively creating solutions and access to clean energy across massive global footprint. How many partnerships evolved to manage demand and as an energy mix shifts?
Yeah, thanks for the question, and hello to that side of the room over there. Sorry, I'll peek around the corner every once in a while to say hello. So Prologis is a large provider of industrial real estate. for logistics purposes. So think about an Amazon package showing up on your porch. It's likely that whatever's in there or whatever it is in your house, 1 in 3 things in your household has gone through a Prologis facility. So I was on a Financial Times panel this morning, and they wanted a more economic answer, so that it's actually 3% of the global GDP will flow through a Prologis facility. So we take that responsibility pretty seriously of thinking about, all right, how do we think in the world as we look to decarbonize? We've got a net zero emissions by 2040 target for our value chain. So we really need to partner with our customers and help them decarbonize. So the first partnership I think of is our partnership with our customers, right? That's natural, but a lot of times people don't think about those necessarily as partnerships, but really as transactions. We really think about it as a partnership. And so as part of that, we're at about 500, a little over 500 megawatts of on-site solar that we've deployed at our facilities globally, with a goal to get to 1 gigawatt by the end of next year. And so in order to execute at that scale, and you're talking hundreds, thousands of rooftops ultimately, it takes a lot of partnerships to get that done. One partnership is with the EPCs that help us design, build, and then operate the systems. It's also with the regulators, so understanding whether it's municipality-based to utility-based, otherwise, really driving strong partnerships there to allow for the installation of those clean energy type solutions. So if you could start with interconnection reform as your first AI, we'd appreciate it. And then beyond that, it's also partnership with our investors. So we're fund managed essentially. So how we work with our investors and investment communities to support these sustainability initiatives is another key partnership. So it does take a village, and as it this collaboration that we're talking about here, I think in every instance, and probably everyone has seen this week, that's a really common and key theme that is required to support true action. We've done a lot of talking over the last decades on sustainability. We got to act and implement.
All right, awesome. Do you see any emerging challenges or emerging opportunities?
Well, I think the integration of systems is a really big one, right? When you start putting on-site solar or battery storage, EV charging, those sorts of things that we're doing, we're essentially building a bunch of different microgrids all around the world. And so how that technology interplays with the grid, the availability of data to make smart predictive decisions, whether using AI or controllers or fuel cells, what have you, that interconnectivity and how the technology works is a really big part of our strategy. And trying to think similarly, as you mentioned, how do we hook up all these sensors into our ecosystem? And then just the other challenge that we have on the horizon is we also, seems to be cutting out. In March, we announced a $25 billion investment in data center development as well, thinking about all the land banks that we have, some of the, let's call it aging industrial infrastructure that sits right in the middle of primetime computing spots. We said, what's the higher and better use for those properties? So I say it's a challenge because it's new for us as a company. And so thinking about operating at that scale of power growth and demand as well, beyond the automation and robotics going into our warehouses, there's a lot on the horizon to figure out, and glad to have partners to be able to do so.
Well, and one thing I might comment on in response to something you just said in terms of opportunities is just what we're seeing is a little bit more collaboration with utility partners. So we've historically competed against the utility, and interconnection's been tough, and there's been a real lack of strategic planning between DERs and what the utility's up to. And the capacity strains have really become so acute that we're seeing some partnerships develop for the first time on our side, and utilities reaching out to sort of suggest how can we work together and think about integrated planning where maybe a DER steps in and solves a near to medium term capacity challenge, but we're thinking about more integrated long-term planning.
Yeah, I agree with that. I mean, establishing a senior level relationships with utilities is absolutely critical for us as well. And then that can then influence, call it the middle layer, where a lot of things get stuck.
Yeah. The company's been around for 20 years. We went public in 2018, and that really brought in a new kind kind of scale for the organization. So we've been focused in the C&I landscape. We've been focused on natural gas fuel cells behind the meter, originally for folks that wanted to save money and move away from the utility. That has transformed into more of a resilience value proposition as well. So as the grids have become more unstable, as precision manufacturers and data centers have come forward and really need 5 nines of reliability the grid can't provide, we've got more folks sort of thinking about that piece of the value proposition. And then on the decarb side, we're highly efficient and provide greenhouse gas reductions today. We, no air quality profile, no water use. So sort of like the Prius of natural gas generation technologies today. But where we see the action moving forward is again on that flexibility piece. So thinking about how you can leverage an asset that you might be able to deploy today to do something that's far more novel down the line. And nobody wants to be locked into a technology for the next 20 years. And we feel like we've got a good starting point, a good value proposition across the sort of 3 legs of the stool, and then a credible migratory pathway as well.
So we've, through this whole climate week so far, we've all seen people talking about let's get to net zero and how do we do this. And I know for many of the people out there looking at this challenge, it's a range, right? We start with 0 and we want to get to 0, or start with 0, get to 100. Tell us if you guys would share anything about this process, or like instead of biting off the whole thing and chewing it all, and what does this look like for customers? What might be your suggestions on going to 20% and 50% and moving from there?
I guess I'll start again. I'll go back to something that Katie had said in the beginning about taking dirty buildings or bad buildings and making them better by following some of these ideas. You're able to take these old industrial buildings, clean them up, reconvert them, and open it up to new economic opportunity for towns and cities. Again, in New England, where we're littered with these old industrial communities all up and down rivers and things like that, taking these steps are very positive. And again, we're not going to go from 0 to 100. This is something that's going to take time. And towns and cities move at the pace of an iceberg. We all know that. But if you want to come to Ansonia and build, we'll waive all building permits for you. So please come on down. But again, you have to put a plan in place. And I think that the most important part is a strategic partnership. I mean, we're fortunate to have that with Johnson Controls. We look at the Johnson Controls team as a part of our operation. So they understand what our strategic plan looks like, what we're trying to accomplish. And they're able to come to the table and work with us to provide these opportunities, again, to not only start to clean up an old industrial city, but give us the opportunity for revenue generation, things like that we can invest in other infrastructure to improve the lives of our residents.
Yeah, I'll just add from the Prologis perspective, we just do math. And Kira Fanning's here somewhere. She did all the math to figure out what's our glide path, right? And I think it's do math and be pragmatic is the way that we think about it. So if the math doesn't work, you got to figure out something new. So I think we're doing a lot of math to figure out where we prioritize. Obviously, that's going to be in markets that provide a friendly environment for a lot of these solutions. Then we know, okay, what are the markets that don't? That's where we need to work on some of those partnerships that are mentioned. And then long term, we're in a couple of hard to abate sectors within its concrete and steel. And so it's also working with the Wholesums of the world to think about that long-term effective change. And so we kind of chunk it in short, medium, and long-term sorts of initiatives, and then redo the math every month, every quarter, every year. And now that regulation's going to sort of force us to do that anyway, it puts in controls in our accounting and finance and all sorts of different systems so that the math is auditable and yeah.
Great.
It's not that simple, though. The math, it's hard.
I don't know, this isn't exactly answering the question, but a thought was triggered that, so I've been working on climate change a really long time, and now that we're getting serious about it, and particularly in the private sector, there's a lot happening, you start to see the need for a lot of dots to be connected for real systemic change to happen. And so when you think about like the set of companies that are up here on the table and how there's all these different pieces of the puzzle, understanding how they connect together, there's a lot of grease that's needed in the system. I don't know how else to put it, right? And when you really start moving the system and flexing the system, trying to change its direction in a significant way, you realize how that a lot. So I'll just give one additional example on AI, and there's just so many areas where information that is needed to take action doesn't exist, right? So I think about companies we're working on their supply chain, and the company has a commitment to making their supply chain more sustainable. Well, like, to make your supply chain more sustainable, you need to understand what the sustainability of your suppliers are. And guess what? In so many cases, that information does not exist. Or if it exists in HTML files or spreadsheets on somebody's computer. It's not yet in a structured manner that you can take action on it. So we see this again and again, as we want to move, paying attention to these kind of interstices in the system, and not losing sight of that as well.
All right.
Great, thank you. Big round of applause for the panel.
All right.